for having me back. When Finton asked me in February if I wanted to speak at Thingmonk, I thought, well, this is going to be my 5th appearance on stage at a Thingmonk event. I can't impossibly give the same talk about data over and over again because there are only so many perspectives you can have on data. So I thought a little bit about what really nagged me about my work that I was doing at the time, and it was people. So for the past year, I've worked for a company called Sulke Engineering in Germany, and there's Mike somewhere here in the audience. He works for our London office if you want to talk about Sulke later on, during the break. So over the last year, I helped Sulke do their IoT work. I provided business consulting, so I explained to customers how they could use IoT in order to improve their products and services. We also work by going into companies and explain those companies how they need to restructure their work and create teams in order to do IoT development. Or we also do IoT development ourselves. So that's the perspective that I'm coming from. I'm immensely nervous about this. And you always look, who are the great speakers in the field? And I thought, well, Simon Wardley would say, if you show a map, you've already sort of like won half of the game. So this is a map of the Roman Empire, very nice 17th century drawing. And that should be my entry point. So some people say the Roman Empire really declined because of organizational issues. So essentially every time they expanded a bit, they founded a new sort of like administrative unit to be in charge, and over time, communicating from Rome to the outskirts of the empire became more and more painful. So they had to manage communication, they had to manage the delivery of assets, and this is very much what I'm seeing quite often in enterprises. So when I talk about organizational structure, what I mean is that unit that really encompasses everything for strategic decision making. So you could have organizational divisions into functions, into geographies, and quite typically, just like the Romans, you have some complex command structure. Now, organizational structure probably is the rise and fall of empires. And just when you look at this Tower of Babel, you can imagine, like, the little man standing there, wondering, who's in charge of our IoT strategy? And then you all know what happened next. And this does not only really apply to IoT, it's all these sort of like cross-functional topics, data science projects, implementing DevOps or agile development in an organization, and doing IoT. Every time when people have to really come together and do their work together, these structural topics come into play. Now obviously this is just a cartoon, and I suppose it doesn't reflect the real organizational structure of these companies. But no matter how companies are organized, there are usually issues around responsibilities, there are processes that people have to adhere to, and the question is, what are the common goals? Right? I'm also going to talk about work on the team level and the profile of professionals, but my entry point now is really the organizational level. What I observed over the last year was in large organizations, there's very often unbalanced responsibility. So you can just about imagine that these entities here somehow have to work together. There is a balance. And then all of a sudden, there's like responsibility for the IoT project for one element, and it's really bringing an imbalance that people don't want. They tend to avoid that, and then projects don't happen. I had one case where the hardware team, it was like physically impossible to get them together with the embedded software developers. And turns out that when we advised them on an IoT product, that they've had that very product idea already 5 years ago. They just never got around to sit around the same table and talk about it. And it was only really uncovered by our work. Also, power play. Whose data is it? Like, well, we did this in our department. Why should we give it to the other department? It's human nature. It's like people have their little territories they want to protect. Processes. We need them in order to work together, but they can sometimes also get into our way. If you have to take all these steps in order to do something, to be allowed to implement a change, it's probably not going to happen. It's much more convenient to just don't do anything. Then the question, should we eat the elephant, and if so, how? We would like to do IoT, but first we need to sort out our big data strategy. But we can't sort out our big data strategy because we're just in the cloud transition. And then it begins from the beginning. We can't really do the cloud transition because we haven't quite decided on the IoT strategy. And you can spend months and months and months on these debates and not do IoT. And I found that rather frustrating. So that's the level I was just talking about. Large strategic decisions within companies. Headache. What about team structure? So rather than looking at the entire organization, we're now looking at individual teams. Those people who actually do the work, get their hands dirty. So they're usually interdependent players, so not individuals. There's a simple command structure. So, these guys are not waiting for Caesar saying, you got to attack now. They probably make that decision on the battlefield for themselves. It's really tactical decision making. And they share their experience as a team. That's the benefit over working alone. Right? And they're multidisciplinary. So some of them might be a little bit more specialized in carrying the shield, others wield the sword, that sort of thing. We observe very much the same in IoT. So if you come from your prototypic IoT architecture to actually developing real products that people want to buy, you're not going to do this on your own. You're going to be in a multidisciplinary team. You're going to have communication. Now, communication between people is intrinsically difficult. You have all the fallacies of distributed systems, but with people, did he get the message? Maybe he got it twice, I don't know. These days, IoT really means scaling people. And we're all moving forward from people who sit there in their spare time and wire together node-RED flows to becoming more professional. But then you look at these numbers. So in 2014, somebody said there's going to be a 4.2 million increase in the number of IoT developers. That number was overthrown. It's like January 2016, why 10 million developers are lining up for the Internet of Things? 2 years ago, ARM said that there's going to be 1 million IoT device designers, so actual hardware people. How do you organize all of that? And this is where not the IT is hard, but hell is others. So what I observed over different sort of company sizes is how people come together to work. So if you're a small startup, essentially all these different skills here, they're unified in the pack. You tend to work together and make those decisions together and just be that team. If you're slightly larger, you might work in what I call the collective. So essentially you sort of randomly decide who's going to work on what with who, and you might have people involved in several projects, and that seems to work quite well. And for those of you who read a little bit about Agile development and DevOps, it's quite a good blog post, Scaling Agile at Spotify, that introduced concepts of essentially squads, tribes, and guilds. And I think we're really looking at sort of like that organizational level. Now, in large organizations, you very often have the matrix. So essentially, you have people of different skills not talking to each other, and they occasionally get to work together in projects where they are kind of like combined together. So if you work in the collective, so the sort of like slightly larger companies where you already have several different projects, self-selection can be a very good strategy to get these teams together. Like, you know, show of hands, who knows about hardware, who knows about software, let's do something. And self-selection actually has a proven track record. So, for example, the crews for the Lancaster bombers were put together by self-selection. So essentially you've got all these people who trained together in a room and said, well, now we need teams of 4. I see you again in 15 minutes. Let's do this. So it doesn't yield chaos. It just means that people who tend to like each other and who sort of have a gut feeling how this could work find themselves together. Now, in contrast, in the matrix, what you have is situations where essentially just by a process, you get thrown together with other people, and it is expected that you independently and efficiently deliver this end-to-end solution. But first, you need to establish communication. You need to establish how other people work, how they think, how they would like to be addressed, what their little specialties might be, and opinions. And already since about 50 years, we know that every time new people come together to have a team, like there's this quite efficient forming period where everyone just wants to present themselves from the best side and like, you know, make an effort. But very soon there comes the storming period where these sort of like friction losses come into play. In a matrix organization with many different projects, you're going through this again and again and again. And I think it's a tremendous loss and waste of energy and time. Of course, only later then, everyone really aligns and performs like they should. Now, quite funnily, when I was reading around these topics, I found wisdom in an unexpected place. It's US Army publication FM60 about knowledge management. And indeed, the military has identified these issues for a long, long time. And there was one interesting bit that I would rephrase as avoid the superhero. It's like, you know, the superhero, the one guy who knows how to work with a certain cloud infrastructure. The person who knows everything about the project, but without him, it's not going to happen. Or without her, we cannot deliver. Right? So they're the operative bottleneck. And I suppose there's the term of the bus factor. Bus factor 1 means if that person gets hit, the project stops. Something you want to avoid. So you might say, if we are an interdisciplinary team, then we don't have that bottleneck anymore. But just adding more skilled people really doesn't make it interdisciplinary. You want everyone in this team to understand what the role of the other person is. So just adding more of these cogwheels doesn't really do anything. You need that to work together. Well, this is one of the reasons I wrote this book, The Technical Foundations of IoT, because I realized that if I work together with people who come from a product engineering background, they will probably not have the same vocabulary that I have as somebody who comes from software. And just if you take a very simple concept of latency, an embedded systems engineer has a different notion of scale when you talk about latency than somebody who's developing a front end. And it's really important that everyone in such a development team has a notion of what certain concepts mean in the language of the others. This is what really true interdisciplinary development means. I very often hear the argument that all this learning that I propose is just a waste of time, and that people should rather concentrate on implementing projects rather than doing strange academic research about why there is electricity in that wire. But I don't agree with that. I think only through understanding really what is what in a complex system, you can understand where the difficulties might be. So you see very often these days these job descriptions that people are looking for the T-shaped engineer. So rather than the traditional, very strong specialization, you want to have people who have some degree of specialization, but who are also very broad in their communication and can really interact with the others in a team. I've seen the F-shaped description of an engineer. So that essentially means that you have a strong technical specialization, but you might have different verticals that you worked in. The pie-shaped engineer takes that to another level where you have probably 2 technical specialties and only 1 vertical. But it really seems that the time of the very focused engineer is very much gone. In distributed systems and the IoT in general, we always face emerging properties. So essentially things where, well, the sum of complexity is larger in that system than just adding up the individual complexities by themselves. And then you think about who is getting engaged in the IoT, who should do that. And there are different schools of thinking, different approaches. And I find very much this conflict between the scientific approach and the engineering approach very nicely depicted on how you'd fix these 2 forks to the glass. That sort of approach might take you slightly longer to figure out, but you know exactly where the weak points of that system are and how it works. Whereas here, you know, it works with Telnet, so why should I worry? And I suppose quite a few in here have that sort of scientific background, and that makes me personally very happy because I suffered for a long time from not being able to say, I'm an engineer, I'm a scientist. Yeah, with that I'm already coming to the end of my presentation. I conclude, IoT isn't hard, people are. And as Judith said this morning, like, you know, a lot of our technical problems have been solved for the last 20 years. Just more of the same. We can't do much about organizational structure. I mean, if you have a large enterprise with many thousand employees, we can't all play like, you know, Montessori school. There's got to be some structure inside. But at least you have to be aware that this might counteract the things that you're trying to do and try to achieve in an organization. And it's been my observation that good project teams require generalists as well as specialists, and probably even more generalists because you need them as social and technical glue. You need them to really make that team gel both on a personal level as well as on a technological level, to act as interpreters, as translators of terminology, so that when I say we have a latency issue to the back-end person, I'm aware it's something different than having a latency issue in the front end or at the hardware level. And with that, I'm done. Thank you.